Good morning. I'm Sue Lessica. I'll be presenting today on two different topics. The first one will be the Nuclear Energy Enabling Technology Reactor Materials topic, which is NEET 3 in the draft topics. The second topic that I'll be discussing is the joint projects between the nuclear science user facilities and NEET reactor materials. So that will be my second topic. So starting first with the NEET 3 NEET reactor materials topic. Again, I'm Sue Lessica. I'm the federal lead for this topic. And we have had a bit of a change in staff recently. Jeremy Busby, who's been my laboratory counterpart since the inception of the program, has moved on to, he will be moving on to a new position, and we wish him well in his new endeavors and thank him for all the great work he's done the last 3 years with us. And I also want to introduce Stuart Malloy from Los Alamos National Lab. He has also been with us since the start of the program, mainly to represent the interests of the fuel cycle group, and he'll now be joining as my laboratory counterpart. So we'll start with an overview of NEET reactor materials. And here you have the text of the vision and the goals of the program. But what the main goal of the research that we support in this area is to look to bridge the gap between the very applied research that's being done within the Office of Nuclear Energy by the specific reactor design areas and the fuel cycle area, very applied research, more applied research, and bridging the gap with the Office of Science research that's being done, which is a much more fundamental type of research. So what we look to fund in this area are cross-cutting research that could apply to more than one reactor type, more than one type of fuel cycle, that is much more of a revolutionary improvement as opposed to evolutionary. So the program began in 2012. That's when we had our first solicitation. And we have an annual research competition that includes the national labs, universities, and industry. And that is going to continue on this year. The duration of the awards is 3 years, as we have done in the past. And the value is up to $1 million per proposal. And that's for the full length of the duration of 3 years. Next couple of slides go over what our ongoing research is, so you get some idea of what we have done in the past. In 2012, the focus was on developing new materials. We were able to fund 9 proposals across a spectrum of material systems. In 2013, our focus was on research for advanced methods of materials characterization and sample preparations, and we were able to fund 7 proposals. 2014, our focus was on advanced joining techniques. And then last year, we went back to our original topic of materials development, and we were able to fund 2 proposals. If you want any more information or description of the type of research we've been supporting, go on to the energy.gov/NE website. That's the Office of Nuclear Energy's website. And in the publication sections, you will find our summary, our annual summaries, and our materials newsletter. Materials newsletter covers a broader topic than just the NEET work. It is a cross-cutting across NE, so it also includes research, materials research that's being done in the applied programs. The annual summaries is in the process of being put up on the website. Hopefully it is there by now, but it may not be, so you may, if it's not there yet, give it a day or two, it will be. So this slide gives you an idea of the vision of the program, where we fund a few ideas, and then every year in the solicitation, and then as things move forward, we can either continue on with follow-on work, as we have with one of the proposals that we received in 2015 that was a continuation of a 2012 award, or things can get transitioned to the programs, to the applied programs, so they can be tailored for those particular applications. So the research competition for this year, the focus, as it was in 2013, is on advanced reactor materials characterization techniques. And there's two sides to that. One is the actual material characterization techniques, so we can better understand microstructure and microstructural changes, how it has an effect on materials behavior in the different reactor environments. And the other portion of it is better sample preparation techniques. As our sample sizes have gotten smaller, we want to be able to use the small amount that we have in a more efficient way. And so that's part of the research that we're looking for in this area. So again, we're looking for a high-risk, high-reward type research, revolutionary changes as opposed to evolutionary. I'll also mention the infrastructure competition. This is not focused only on materials. However, materials is one of the components of it. It is open to the national labs. And I encourage those from the national labs to take a look at this and propose some modern material science capabilities that would really support the Office of Nuclear Energy's research in materials. Last year, we were able to fund one proposal in the materials area. Again, this is open to other areas as well, but please take a look at it, and I just wanted to advertise. So here's our contact information for myself and Stu. If you have any questions, want to talk things over, please feel free to contact either one of us. Next, I'll transition into the joint, I have a typo here, it's the nuclear science user facilities and NEET research projects. This is the focus on the NEET materials. Yesterday, you heard talks on how these joint projects would work. I won't go over that. I will just focus on the technical topics for the materials area. So the first topic is separation effects for fission product behavior. Madeline Feltus yesterday talked a little bit about a topic that was focused on separate effects for TRISO fuel. This topic is similar, however, it is much more broad. It is open to any of the fuel forms that are relevant to the mission of the Office of Nuclear Energy. So here, the separate effects we're talking about are on transport mechanisms, how the fission products have effect on fuel cladding chemical interactions, and of course, with separate effects, modeling is the big driver. The next topic is irradiation-assisted stress corrosion cracking. Better understanding of this phenomena. The NSUF capabilities are particularly strong for light water reactor materials. However, this topic is not restricted only to light water reactors, so it is open to other reactor design environments and materials. The next topic is irradiation testing of materials produced by innovative manufacturing techniques. And I'm presenting this on behalf of my colleague Alison Hahn, who wasn't able to be here today to do it. But this topic is looking at irradiation testing of materials and components that have been fabricated using advanced and innovative manufacturing techniques. Because these advanced techniques may have an effect on microstructure, we need to look at what the irradiation effects are. And the third topic, experiments with synchrotron radiation at the advanced photon source. This topic focuses on developing a better fundamental understanding of materials in irradiation environments. And so the description here talks about what the different capabilities are. But the goals here is a very efficient mechanism, capability to do some fundamental studies on new materials and different types. And that's the end of my presentation, so I'll be happy to answer questions as they come up.
Let's start on NEET 3. Is characterization of HT9 steel at DPA values much larger than 200 an area of interest?
Well, this topic is to develop advanced techniques as opposed to doing specific research on a specific material. So if the proposer is looking to develop a new technique for this metal or other alloys, then that would certainly be within the scope.
Can new materials be proposed to NEET 3 as long as advanced characterization tools are used to characterize?
No, the focus of this scope is the development of advanced tools, new tools, as opposed to doing research on the material itself.
To what extent are high throughput experimental techniques for rapid new materials characterization encouraged?
That would certainly fit well into the solicitation and is of interest to NE, and actually across the department there's a big push on high throughput techniques. So certainly that would be part of the within the scope.
Would infrastructure resources be provided for universities to install or upgrade computer clusters?
That
may be more directed towards the infrastructure college,
yeah,
I believe was asked yesterday.
Okay. That's more, this is much more focused on research.
On NEET 3, this year will you only accept proposals for characterization techniques and tools and not consider proposals for development of materials?
That's correct. Our focus is only materials characterization and sample prep techniques.
Can ideas on advanced materials fabrication or joining be acceptable?
Nope. Again, no. The focus is on advanced characterization tools and sample prep.
Is characterizing concrete materials under irradiation considered?
Yes.
Does the innovative MFG techniques in 1.3C have to be used on existing materials, or can they be on new materials?
The focus here is on developing a new tool, and it sounds like the question is on using a current tool.
We'll see if we can get clarification.
Yeah, that would be great.
On the NEET NSUF IASCC, what is the focus? Materials development or new techniques?
It would be materials development. It's understanding the phenomena of stress corrosion cracking in materials. So it could be advanced materials. It could be materials that are currently in use in the nuclear industry.
Yeah, we have a clarification on the question that was confusing.
Okay.
PI says 1.3C asks for radiation testing produced via innovative processing. Does the innovative processing have to be on existing materials, or can it be on new materials?
Okay, this was the NEET, the NSUF topic. It could be, I think, it could be new materials as long as or older materials as long as they have been developed, fabricated using the advanced manufacturing techniques. Again, the focus here is the materials fabricated by advanced techniques.
Are new reflector materials considered in any of these scopes?
No, I don't see how that would fit in any of the scopes. Well, perhaps in 1D, the experiments with the synchrotron. That's a very wide topic on what type of material could be researched. So perhaps 1.3D would fit under that scope.